In this video, we are going to talk about another condition under conditional permutation. In the previous lesson, we spoke about a condition where objects must not be together, and then we understood how to go about it. Here, we are going to consider a condition where objects are placed in specific positions. So when this is done, how can we tackle such questions? Let's proceed. When certain object must occupy a fixed position, the first strategy is to place the objects in their required fixed position. This usually means one way to place them if they are specific objects. This usually means one way to place them if they are specific objects. Now, the second step is arrange the remaining objects in the remaining positions. So let's see an example to illustrate this. So this example states that how many 5-letter arrangement can be formed from the letters A, B, C, D, and then E, F, and J, such that A is always at the beginning. A is always at the beginning and J is always at the end. So the condition is that A in the first position, J in the last position. So what you do is that your first step is to ensure that you have to place the letters in their respective positions first. A will be at the first, so here we write our A at the first position and then this at the last position. That's what we have. And if this is done, we have 3 possible positions remaining to be filled. 3 possible remaining positions to be filled, because we are to form 5-letter arrangement. 5-letter arrangement of these letters. 5-letter arrangement of these letters. Sorry. So when A is placed at the first position and J is at the last position, there are 3 remaining, because 2 out of 5 is 3. So there are 3 5 letters, and these 3 5 letters that are to be part of this A and then J in their respective positions is to be taken from the remaining letters, which is B, C, D, and F. B, C, D, E, and then F. So we are going to take this remaining 3 letters that must be part of the 5-letter arrangement. That must be part of the 5-letter arrangement from a total of 5 letters. That is B, C, D, and then F. So first of all, let me be very brief and simple here. What you need to do when object must be placed in a very specific position, what you do is that first of all, place the object that are mentioned in the question in their respective positions. So here A is to be at the first position. A is to be at the first position and J is to be at the last position. Now place them. How many letters are you taking at a time? Or how many letters are you arranging out of the total? How many letters are you arranging out of the total? And how many possible ways can this be done? So here we are arranging 5 letters out of the total number of letters. We are arranging 5 letters out of the total number of letters. And then we have A and J to have a specified position. A is at the first position and J is at the last position. So what you do is that just place the letters identified or the object identified in the question in their respective positions. Now we place A in the first position and then J in the last position. Now we need 5 letters to form the arrangement. So how many positions are left? So we place the dots. You realize that we have 3 dots in between them, because A and last, there are 3 letters that must be filled in order to get the 5-letter arrangement. The 5-letter arrangement. So these 3 letters are going to be selected. Now we have a total of 7 letters. That is A, B, C, D, E, F, and then J. And then 2 have been selected. So we have a total of 7 letters, and then 2 have been selected. Now we are going to select 3 letters out of these 5 remaining letters to fill that position. And how many ways can this be done? So this is very simple. Taking 3 letters at a time from 5 letters, five possible letters. It means that we can use possible permutation, because we are going to arrange. And then here, order is very important. Order is very important. So here, the 3 letters available for the position. And then, so the last arrangement, the last step is to arrange these 5 letters in the available position. So you see, it's very close to what we did earlier. It's very close to what we did earlier, but here the positions have been specified. The positions have been specified. So you realize that when the objects were together, or when the objects were not even together, we also use the positions, right? The spaces that are available. So in the previous video, we spoke about where objects are not together. So the possible spaces were the spaces that we fill this objects that are not together into. But here you realize that we have objects in their specified position and there are some spaces left. So how do we fill that space? So we are going to select, after taking those 2 letters from the total of 7, we got 5 remaining. So we are going to select 3 letters from this, and that's permutation. So 3 from 5 is going to be, always, as I said, subtract the number that you are dealing with from the total. So we subtract 3 and we go 2 factorial. So 5 over 2 factorial give a total of 6 ways. Give a total of 60 ways. Please, here we are not multiplying. Because you are taking a total. We want to know the number of ways that this 3 only can be arranged. We don't need any multiplication, so you take note. Thanks for watching, and let's meet in the next video. Bye.